My name is John Nicholson. I'm a Senior Technical Marketing Manager. Obviously, the topic today here is vSAN Network Deep Dive. In case any of you got lost and were looking for something else, that's what we're going to talk about. So I wanted to get into things. First off, we've got our standard disclaimer. Try to keep the flash photography to a minimum. This presentation may contain features and things that are under development. And on the agenda, we've got two areas we want to cover today. The first is general virtual SAN networking, best practices, how it works, what's going on from an operations side. And then my partner in crime here will get into stretch clustering. So virtual SAN, just a quick primer in case you haven't worked with it before, it leverages local disks and servers and builds a cluster of hosts to provide a highly available data store. Data is replicated or mirrored or protected by a distributed RAID across the cluster. Now, when you're deploying it for networking, it uses its own VM kernel port type. And so if you've set up a VM kernel port for, say, vMotion or management or things like that, there's a little checkbox you check. We've got the exact same thing going here. Now, within the vSphere world of networking, we've got two different switch types. We've got the standard switch, which you probably all know and love, and then we've got the virtual distributed switch, which I can't underemphasize how awesome it is from its capabilities. Historically, not everyone may have had VDS because it was tied in licensing to Enterprise Plus, I believe. Mm-hmm. Some nods, there we go. With virtual SAN, the virtual distributed switch is included. So don't let licensing be an object to deploy it. And while we do support both, I highly encourage you to go with virtual distributed switch. So the virtual distributed switch, when you're creating a port group under the legacy standard switch, you'd have to define the port group on every single host, and you had to manage basically each switch as a standalone. The virtual distributed switch lets you create a port group for things like vSAN traffic once, and then enforce consistency across. So this removes not only a lot of manual work, but also a lot of duplication of effort and opportunity for mistakes. So one thing with any type of storage traffic is you want to make sure you have great performance. And part of that is also in some environments, historically, if you go back to the dark ages, of dedicated fiber channel networks and things, we had dedicated networks. And we had to dedicate networks because there was no way to guarantee performance. Now in VMware, we created a technology called Network I/O control. And this works at multiple levels. We've got Network I/O control now that can actually extend all the way to the virtual machine and prioritize individual virtual machines. But also on the distributed switch, which is required for Network I/O control, and again, why I recommend it, you can create different traffic shares and queues. And so you can prioritize traffic. It basically does a shaping as the traffic leaves. This is relatively low overhead. And opposed to other ways you may have done this in the past, like converged network adapters, if you worked with blades and things like that, this is a lot more adaptive and flexible. You can change this on the fly. You're not creating actual hard interfaces or things like that to devote traffic. Really want to make sure you're getting the best out of this. Now, that said, we do have some customers there who love their dedicated storage networks. I'd say probably about 35% of the customers I talk to still deploy a dedicated storage network. Looking for a nod, yes or no here. But no, there we go. That sounds fair. That said, the majority of our customers, they just take two 10 gig, and soon probably next year, 225 as that becomes more mainstream to their host, and they basically mix vMotion, vSAN, fault traffic, not necessarily fault tolerance, that one you generally still break out, management traffic and all in there. And so depending on your topology and your requirements, you can go either way, but don't feel that you're forced to deploy a separate standalone switch because this technology is there and available. And I've got an example here of different types of traffic shares. And some things to quick note on Network I/O control. It is incredibly powerful. But there's also a lot of things that you can do bad very quickly if you don't know what you're doing. So I will warn you. There are limits, so you could hard limit and prevent something from going higher. That's 99% of the time an awful idea to use. Because someone will set a limit of something too low, and you'll end up having to chase that down. The other thing is you can also set reservations and say, I want to reserve 1 gigabyte of traffic for vSAN or vMotion. And while the different types of VM kernel port traffic that are noted here, with the exception of virtual machine traffic, they will share when there's, they're not using their allocated reservation. The problem is they will never yield that traffic that's reserved back to a virtual machine queue. So if you set reservations, again, they can be dangerous, even though they are flexible. So really what we recommend is use the shares. And here's an example of a sample recommendations. My general recommendation is turn Network I/O control on. It's a checkbox on the VDS. And then leave it alone unless you have problems. In the majority of environments, you're not hitting throughput 100% of the time. It's typically only on small microbursts and times like that. And the shares there, the general shares, will protect you. Now, one misconception that's been out there is in terms of how you connect to your switching is that virtual SAN can't use multiple links coming out of a host. Now, for simplicity, and if you're in a small environment, you're not pushing performance, you can obviously use virtual port ID and set an active passive failover pair, and a lot of people do that, particularly if you're using standard switching. They'll send vMotion down one, vSAN down the other, as they're a bit more I/O intensive. That said, if you are using IP hash, or if you're using the virtual distributed switch lag functionality, there's about a dozen extra hashes that open up. Virtual SAN, the IP hash, how that works is a connection between two sets of IPs will always follow one path. But if you've got multiple hosts talking to multiple hosts, as happens in a vSAN cluster, they'll end up routing out those two different paths to the different switches. One thing to note is this is not a perfect load balancing. You're not going to see 80% and 80%. It's very common when you're using IP hash to see 30% and 80%. I'll call it kind of dumb load balancing in a way. So it will help you with throughput, but again, often throughput is not the primary concern in environments. It's typically latency or I/O of the disk and capacity and storage. So going through again, when you're setting that up, we've got a couple of examples here. When you're setting up LECP, one thing to note is if you've got just standard switches that you've got switch A and switch B, you don't want to use IP hash talking to both of them. In order to use any type of intelligent link aggregation like LECP or IP hash, this requires those switches act as one in some form. So that can be from a chassis talking to different chassis line cards, or this can be also in the form of like a stacked switch and have that awareness or have a multi-lag awareness. So it's one thing to watch. Now, troubleshooting. Now, here I've got an example on the VDS of what the different ports look like in terms of that. So with standard, again, we recommend that active standby just because you don't have network I/O control. And so this is going to be your best way to make sure you don't have a case of vMotion stepping on your storage traffic, just as it's the other major throughput demand. And for that, you set virtual port ID, and you set this up. And then with LACP, you can either use the default IP hash, or again, if you go through the advanced lag, you can go to those more advanced. And there's some hashes that will actually use source and destination port, so you can potentially use both links for two hosts. Again, that's not going to be a perfect link balancing, but it will get you something. Now, I do get asked about virtual SAN. Should we be setting up an entire separate TCP/IP stack? And this is obviously an option today to improve performance for things like vMotion. Today, we do not do this for vSAN. But I did want to show how, again, you've got the different VM kernel ports within here and how we've got vMotion off on its own. And I would recommend putting vMotion off on its own for performance reasons. So multicast. This is the slide I'm sure you're all waiting for. So one quick misconception I want to clear is virtual SAN does use multicast today. But virtual SAN does not use multicast for all traffic. Only uses it for metadata and state awareness, which is a very small, it's less than 1% of traffic. The actual SCSI payload packets, the actual data, that is unicast traffic directly between the hosts. So multicast can be configured in two different ways. You can have both a layer 2 and layer 3 deployment topology, and it's managed using protocols like IGMP. You use snooping and queries to register, and when you're routing, you use things like PEM-sparse and dense mode. Now, there's a couple different ways to enable this in smaller environments. A common way, if you're actually using cheaper switches, this can actually oddly be faster sometimes, is you set each cluster up on its own VLAN, which, by the way, is my recommendation and best practices. If you're doing layer 2, try to give each vSAN cluster its own VLAN. There's a couple of benefits I'll get to later on this. And you can either set up the querier, or if you've got a really low-end switch, maybe the querier performance isn't as good, like this is a lab or something, you can actually disable snooping, in which case that multicast traffic will go to every port on that VLAN. Just make sure the only thing on that port are actual members of that cluster. Now, obviously, higher quality enterprise-grade switches will get the best multicast performance results, and I've got some slides later to show a performance test. That said, test out your switches, look at that. You'd be surprised occasionally some of the big vendors, they've had bugs and quick discovery of, hey, why is my really, really expensive switch performing bad? You do a quick call, and you get a quick patch to fix that. So, and that's one thing we want to make sure is you test the stuff before you go operational, specifically on the networking side. So getting into layer 2 versus layer 3, there's a couple different, schools of thought in why you might go one way or the other. With layer 3, I typically, in environments where you've got a hard mandate for leaf spine, that layer 2 will never cross from one top of rack switch to another. Or if you're doing things like fault tolerance. So vSAN, you can split a cluster across multiple cabinets or multiple pods in a data center. Today, you can't generally cut your existing storage array in half. And so for fault tolerance, you want to make sure that traffic's mirrored to different sites. This is a case where people may be doing a layer 3 deployment. The other one, typically, if a vSAN cluster is all staying within the same rack, our general guidance and what we're generally going to see is layer 2 be the primary deployment there. Now, for multicast addresses, when you tell your networking team, which maybe some of you, anyone in here actually a networking guy? We got a couple of you. Everyone be nice to them later. So here are the ports, and here are the default addresses. You've got 2 on the cluster. You've got the group multicast address, which you'll see a fair amount of traffic, and then you've got the master group multicast address. This one you'll typically only see, 2 hosts communicating with, typically? So don't freak out when you don't see everything registered to these addresses. That's not necessarily a bad thing. And these are the ports. Now note, if you are going to deploy, let's say your networking admin, these guys in the back here, who shall remain nameless, let's say they are treating VLANs as a precious commodity, a natural resource that must be preserved. Yes, everyone's been in this environment before. Or change control. It just takes, 6 months to get an extra VLAN. You can run multiple clusters on the same layer 2 segment. Just make sure you change both of these addresses for each, hit next there. Make sure you change both of these addresses for each group of clusters. Otherwise, the multiple clusters will start talking to each other. You'll get a fun little alarm that says rogue host detected. And eventually, if you get enough of these clusters talking together, they'll turn into transformers and try to take over the world. So vSAN's very smart. We need to make sure those clusters stay separated. One thing to note, and so here's the actual ESXi command. Obviously, you can script this with PowerShell pretty quickly. So from a security domain perspective, vSAN is just like iSCSI, it's just like NFS, it's just like Fiber Channel, and that it natively to the protocol does not do end-to-end encryption. So you want to make sure you don't route into your vSAN network from random desktop networks, just like you would protect your NFS or your iSCSI. And this also means if you've got things that are in different security contexts, like you want to isolate your DMZ, from a security mandate from other networks, make sure those, even if you are sharing VLANs for different clusters, make sure maybe those DMZ ones are grouped together and separate from the other ones. So that way you don't have any type of risk of back end from a security standpoint. And this is similar how you would have separate hard zoning possibly in Fiber Channel. This is nothing really new. This is just taking existing security hardening concepts and moving them to the virtual SAN world. So getting back to some kind of simplifying the layer 2 versus layer 3 choice. If you've got the least complex implementation is going to be layer 2. This should be your default assumption unless you've got something telling you otherwise. You're dependent on the extension of logical networks. This is much simpler to deploy. It's much faster. It's much easier to troubleshoot. And it requires less skill. The other one is layer 3 topology. This is going to be more complex. This is typically environments that are larger, where you're spanning across multiple cabinets. You're leveraging the fault tolerance. And you're actually routing multicast, which is not quite as bad as it sounds, I promise. So NSX, this is always the thing every network guy. Anyone in here running NSX? Thinking, POCing. There we go. Glad to see you guys. So virtual SAN and NSX fully interop. And to describe that, if you think about it, so NSX best practices, you do not encapsulate your back-end management, just because that can create a fun chicken-egg circular dependency. You don't encapsulate iSCSI. You don't encapsulate NFS. You don't encapsulate your storage traffic. Virtual SAN is just the same way. It's a VM kernel port. It still gets its own VLAN. You're not encapsulating it. Think of it as they coexist peaceably. And a fun thing is virtual SAN is managed by policy. So we define things like failure to tolerate, cache performance, IOPS, things like that from a policy-driven engine. using our SPBM. Our friends over in the NSBU with NSX, they're driving security by policy and creating security policies and automating that. So the same types of operational concepts that those guys have, we have those, API-driven automation of policy and things like that. But that's why we play nice together in terms of things like realize automation. We just had a plugin release for that. So they go great together, but just don't encapsulate them in that. Now, one thing to note on that limitation is if you do want to, let's say you have a layer 3 topology, or but you really want to get that layer 2 experience, and that's why you're considering wrapping NSX in that, there are other ways to do that. If you can do hardware VXLAN, or if you have a proprietary equal cost multipath layer 2 fabric, so like your Brocade VDX, VCS, ACI, fabric path, so forth, that can, at the hardware level, extend layer 2 between that, vSAN is more than happy to ride on top of that. So link speed. And this is actually another thing when I talk to the network guys, they're always asking about is, not only how many ports, everyone always focuses initially on how many ports from the host, but really if you think about it, when you have a clustered distributed system, there's a fair amount of traffic going between the hosts because the data is not always local, or writes always have to acknowledge to 2 hosts. And as the system scales, you're going to have more throughput demands. And as when you have a simple vSAN deployment, you got a small cluster talking to the same top of rack stack, you've got full cut through, great performance, no worries, right? When you start splitting vSAN up and deploying it across pods or data centers or floors, doing fault tolerance, you've got 64 node clusters, and maybe you can't stuff 64 onto the same switch. You start oversubscribing ports, and that's fine. But watch your oversubscription ratios. Because the biggest event that you need to size for is the loss of a host. Because when a host is lost, you're going to have rebuilds. And if you're leveraging fault tolerant, or not, if you're leveraging the fault domain concept, to where vSAN makes sure to keep copies on different cabinets and things like that, let's say you had 20 terabytes of data. When you have a host failure, you now have 20 terabytes. It's got to go from here to here. And that's fine, assuming you give it enough throughput. Other thing to watch out for is there are some devices out there that call themselves switches, but are not switches. I'm going to call out Cisco fabric extenders, commonly known as Nexus 2000s. They lack any east-west capability. There is no way for this port right here to talk to this port over here without going all the way up to the uplink, all the way back. Now, those are becoming less common. Yes, that's the appropriate angry face right there. These are becoming less common in the field, but, switching, 10 gig cut-through rate switching is not that expensive. You can get some good enterprise gear. You can get a pair of, switches for 15 grand without a problem. This is not something that, for a POC or a very small environment, you could still use a 2K. Just make sure you've got a lot of uplinks going here. But really, you want low latency, you want good buffers, you want dedicated east-west capability. And so that's one thing to watch. The other thing is this is what's known as a leaf spine topology here, where you've got your top of racks, and those all sync back to a spine switch. This is very flat, very simple. There's no spanning tree involved in this. In fact, if we were doing some type of wild ECMP, you might even have some looped connections going in here. I know that scares some people. If you've got a legacy, what's known as a 3-tier network design, core aggregation, all of that going forward, there's a lot of spanning tree going on. There's a lot of links that they may exist, but typical 3-tier network design, you've got 42% or something of throughput is effectively can't be leveraged because links are held down by spanning tree. So if you're deploying vSAN, talk to your networking teams about leaf spine. If you're a networking guy, go talk to the NSBU, talk to the NSX guys. They really love talking about leaf spine, even more than I like talking about storage. It's kind of crazy. The other thing also on here I wanted to note is blade chassis. We really recommend rack mount servers, although blade chassis are strangely I'm getting more asked just because you can get 4 terabyte flash devices. So previously with the only 2 drive bays or being limited to storage blades or things like that for cost reasons, blades generally were only done for brownfield reasons, but they are coming back. One thing to watch is often people will have switches embedded in their blade chassis if they're not doing pass-through, and that's another opportunity for oversubscription that may not be tracked or people may be aware of in their network design. So let's talk about network troubleshooting. So what's the first thing the networking guy says to you when he says, I think there's a problem with the network? See a smile. You're wrong. And And we love our networking guys. I used to be one on Tuesdays when, people forced me to. But we used to have a lot of fun CLI things, and I call that the hard way. Instead, we've now got the easy way. So we've got what's called the Virtual SAN Health UI. This used to be a plugin. It's now a native piece as of 6.2. And we've got dozens and dozens of different checks, everything from checking the HCL and firmware for devices, to looking at networking configs, to trying to detect network partitions, looking for inconsistencies in configuration. This is a powerful tool that's being iterated very quickly. Because we know and we work with GSS directly to make sure the leading cause of issues or confusion in configuration or setup are being tracked in here. And we want to make sure when you go into protection with vSAN, you've had, all of the major common things that could be misconfigured have been watched for and looked for. Going through this will check for, connection failures. This will even check if you've got, maybe someone went crazy and had a port they plugged in that's at 10 meg or something crazy. It'll detect things like that, link speed. The other thing is also we've got these passive checks that are running in the background, constantly monitoring your environment. We also have some active performance tests. Everyone should be excited about this because how many times have you set up an environment, you tested something, maybe in your lab, you put 1 or 2 VMs on it. Oh, this is great. Let's move the next 200 in. Something happened. You're like, maybe you had a fiber channel buffer credit exhaust. There was something that as you started stressing your storage network or stressing your environment, you didn't discover. Maybe there was a firmware in a device or something that you weren't tracking. So we've got several tests here. One, we'll test VM creation. And this will just make sure everything can talk to each other. So if a host can't create a VM, there's potentially a problem there's just an outright network connection problem. We'll also test multicast performance, which is something I know all of you know how to test already, but we put an easy button on there. We'll also test storage performance. We've got different profiles and different tests. So you can do write heavy, read heavy, cache, non-cache. And this gives you a quick sanity check. We do have better tools. We've got HCI bench if you really want to push the limits of storage. And some of our guys in product enablement they can do some really cool, let's show you, millions of IOPS in your cluster and stuff like that. Think of this performance test really as a sanity check. If 2 of the hosts are putting out 80,000 IOPS and one's putting out 4,000 IOPS, and they're exactly the same, that's probably time to go hunting for something. The other thing is we've got tons of built-in alerts. Beyond this, also we've got roll-ups into VROPS. So if you've got multiple clusters, you want to look at that. We've got dashboards as part of the storage management pack. All you need is VROPS standard for that. Normally you need advanced for storage, but for vSAN you can get away with standard. The other thing is also Log Insight, which is a tool you all should have deployed in your environment. It is amazing. Log Insight, there are dashboards for vSAN. And we are now, I think this quietly snuck out as of 6.2, I hear, traces, which previously were only logged locally because of incredible throughput demands. We would break syslog if we put them in there. Urgent instances in the vSAN traces now actually feed into the syslog. And that's typically why GSS was asking you for your logs anyway. So now you can look for the crazy cool outliers and things like that. I wanted to talk really quick about a couple myths. So there's been a lot of myths and confusion about certain things requiring networking. The first is that multicast requires a CCIE to accomplish. Particularly layer 2 multicast, this is like 2 commands, guys. You create a VLAN. You make sure snooping's enabled, set up a querier, you're done. If you go to layer 3, you got routing, but you're using routing protocols. Make sure, if it's a large environment, limit that routing only from one vSAN cluster to another. Don't route everywhere and run dense mode and, flood the entire WAN with multicast. There's some silly things you can do at layer 3, but again, your networking guys should be competent. They don't need a full CCIE even to do that. The other thing is also, there's this myth that jumbo frames are somehow required. And somewhere back in the Stone Ages, we used to have a lot of CPU overhead when we sent a lot of small packets. And storage is often lots of small packets. Or even large, we had large packets and we had, frame overheads and things like that. This is back in, 2007. You had to sit there and the CPU had to sit there and slam and generate a checksum for TCP, CRC32. Starting with the Xeon 5500, circa 2008. CRC32 was an offloaded function. In fact, we use it for checksumming with vSAN, to where like a single core could push 1 million IOPS. So There are other benefits in terms of, in theory, throughput efficiency, but it's really tiny. And that's only if you're sitting there doing large streaming reads and writes all day, which is not most people's blender of a IO blender of a virtualization environment. There are some marginal, if you're pushing the limits of NVMe, like you're one of those customers who's all NVMe on your vSAN today, and you're trying to squeeze every last ounce out of that CPU. Yeah, you can get a couple percent CPU back potentially, but this is not something. Don't go configure jumbos just because of vSAN. Configure it because of NSX, because you need it for encapsulation. Configure it maybe for vMotion because you've got crazy amounts of memory density and you want to squeeze some extra performance and CPU reduction when you're doing large vMotions back and forth. But don't deploy jumbos just because of us. No, it doesn't hurt. There's nothing bad. So, yeah, and you can do all 9,000. Where you get in trouble with them, and everyone, some people get scared of jumbos. Where you get in trouble with jumbos is if the devices on the end are trying to speak jumbos, and the virtual switches or the switches in the middle are not, and you end up with stuff getting fragmented. And you get, actually the error, it's called a giant, I believe, if I'm not mistaken, on the port counter. Looking for a nod. It's been a while since I stared at iOS. So
basically, you're recommending to just keep it at the 1500 so that we don't find that inconsistency somewhere down the path. It's just a lot easier.
Well, I mean, it depends. So if you're staying all within the same top of racks, it's pretty easy to configure. But it all depends. Again, there's not a huge benefit for us for that. There are benefits in other systems. And for instance, if you're going to deploy NSX or any type of overlay, you're going to need an MTU larger than 1500. So, but don't look at us as the driving force or storage even in general. I mean, you go ask our peers, Vonster and others, they'll rant about, the overratedness of jumbo frames and storage just because how most of the reasons why aren't really true anymore. Getting back to data locality here, this is something that comes up that my data has to live, all of the data needs to live right next to the virtual machine. Or maybe Virtual SAN does this, one write's always local. Virtual SAN today, and I say today, we've already changed our file system and our data structure layout twice now. We're on version 3. Mm-hmm. I'm sure there's somewhere in the bowels of version 4, not a forward-looking statement being worked on. We're an object system, so fundamentally we can change our data layouts. Today, the port-to-port latency is incredibly low on modern 10 gig switching. You can get port-to-port latencies in 350 nanoseconds. The fastest flash devices you're going to get realistically, NVMe devices, they're in microseconds, which is the next hop up if you remember your Latin metric prefixes. So yes, there is a tiny bit of latency added by reaching out over the network. And yes, there's a throughput concern, but a write always had to hit the network anyways. This is not something, the network is not going to introduce latency. When you get it, where you get latency is when you talk to a SATA-based SSD and you go all the way down to queued up 32 and you stack your SCSI commands on top of each other. That's where you can actually get 2 or 3 milliseconds out of a flash device. It's not being driven by the network. It's being driven by the HBA. As persistent memory technologies change, this may change. And again, vSAN, we change with the times. The other thing also here is I talk about, we do use data locality in 2 cases. And these are important cases where the storage layer access would be lower latency than the network. One is stretch clustering. So we allow, which he'll get to later, we get to a 5 milliseconds is what we allow for that stretch cluster. And so obviously you don't want to go read across 5 milliseconds and add that. Writes, you have to pay that penalty. That's physics if you want to make sure you have synchronous replication. But also with client, so we will read only from the local site. Now you can override that if you have a low latency link. There's a command. Jace has that. The other thing also is that I wanted to talk real quick on is client cache. So we do DRAM caching. We use RAM for caching. There's 1 gig of RAM, 0.4% up to 1 gig, 1 gig in most cases. RAM has very low latency. And so because of that, that latency is lower even than the network. And so we're going to read, that will follow the VM, so to speak. But it's a very small amount of data. We're not having to incur a data migration when we start moving VMs around, which can impact DRS. There's some people out there who like to have lots of data follow the VM. They often recommend you turn off DRS. So we have full compatibility across our products. We don't have problems as we scale. And that's something we wanted to maintain. One other thing is in your environment, and your network guys should know what this is, turn on LLDP or CDP. So either link layer discovery protocol or Cisco discovery protocol. By default, it's just on for CDP on a standard switch. I've got the actual screen of what it looks like, and make sure you turn it on for both send and receive. So what this does is this allows you to click, as you can see in that bottom screen, and see, when I'm yelling at my network guy of, hey, this VLAN's not configured for this port, I can give him the exact switch, make, and model, what its chassis ID is, and what its management address is. So I can make sure we're talking about the same switch, because I've seen some people almost come to blows on conference calls because they were talking about the wrong ports. The other thing is when you turn it on for send, your networking guy can now run show CDP neighbor, show LDP neighbor, and he can see which hosts are behind which ports. So you get top-down and bottom-up visibility. This prevents a lot of anger and rage when you're troubleshooting something at 3 a.m. And again, if your networking guy really wants you to prove that there's a problem with multicast, here's how you do a raw TCP capture dump. And this is out there. There's a KB on this. So with that, I'm going to hand off.
All right. Thank you, John. Can you guys hear me okay? All right. So I'm going to be talking about stretch clusters. So I'm Ankur Pai. I'm an engineering manager in the vSAN team. So how many of you here are already using vSAN stretch cluster? So anybody using it already? Okay, quite a few people. So before we start, I want to say one thing real quick. The same technology that we use to build out vSAN stretch clusters also enable a 2-node robo or remote office branch office solution. I know you guys use it, but any other people in the room who are using 2-node robo? A few people. Okay. All right. Okay. So for those of you who are not familiar with this, vSAN stretch cluster is a solution where you have 2 sites across larger geographic distances where you want to do them as active sites. So the writes are actually in sync, like John was alluding to. So one thing I want to call out here is you do need sites for this. So there are 2 sites which are your active vSAN sites, but there's also, you need a 3rd site where you run that witness right over there. Many people have asked about this. No, that cannot be co-located with one of the sites. We really need those 3 different fault domains. We don't want 2 of those things failing at the same time. Other than that, quick thing about licensing, nothing relevant to networking per se, but you need vSphere 6.0 update 1 that applies to both vCenter and ESX. You need vSAN enterprise license for this feature. Highly recommend the use of DRS, just like even regular vSAN. And for that, you need vSphere enterprise license. The witness, like I said, needs to be in a different fault domain from the 2 sites. Usually we see that people run this in the management cluster, like data center where your VC runs, something like that. So you need that site. The witness can either be a physical ESX box, but in which case you will need a vSphere license for it. So I don't know why anybody would do that. We do support running that witness as a VM. It's a ESXi VM, a dedicated VM just for vSAN stretch cluster or robo. It comes pre-packaged as an OVA.
I think this is our only case of a nested ESXi instance ever being supported.
Correct. So we call it ESXi VM. And I mean, it could enable nested, but do not run any more VMs on it. That will not work. We disable that. All right. And you also need on-disk format V2, which is what got introduced in 6.0, I believe, vSphere 6.0. So you need that V2 format for stretch cluster. All right. So let's talk about networking requirements between the data sites. So we do recommend similar L2 even across data sites. So it'll be an L2 stretched. Like John was saying, L3 works for this also, but again, that creates kind of complex topologies. So we do recommend an L2 stretched even between the sites. We do need multicast, by the way, because many of the things that John spoke about do apply to stretch clusters. So we still need multicast between the 2 sites. Again, there's no I/O that goes on multicast. That's all unicast. What goes on the multicast is metadata and state. The latency requirements across the 2 sites is 5 milliseconds round trip. So you have to be less than 5 milliseconds. Now, at this point, I would also like to call out that though the similar technology powers robo, remote office branch office, the requirements for that may be a little bit different in this, and I don't remember all the numbers top of my head, but the stretch cluster sizing guide has the different numbers even for robo versus stretch. So for stretch, it's 5 milliseconds or less. The bandwidth between the 2 data sites, again, is 10 Gbps, as with a regular vSAN cluster, because like John was saying, it's still mirrored, because they're active sites, the writes are in sync, so writes go across those 2 sites. So we still recommend 10 Gbps. Oh, that's exactly right. And also resyncs, because we have copies of the same object across sites. So if you have a disk failure or a node failure, we have to resync across sites. So it's important that that be 10 Gbps. You can go with 1 Gbps that's supported, strictly speaking, just like regular vSAN, but you run some of the same problems. And like John was saying, 1 gigabits per second is like 100 Mbps. You don't want to be bottlenecked by that, because SSDs can do quite a bit more than that, even right now, even without NVMe and so on. Let me see. It looks like I covered most of that. So we'll go into some detailed calculations of how to estimate these things in the next slides. All right. So talking about the requirements across the witness. Now, the witness is not in the I/O path. There's no I/O that goes to the witness. Only things like change of policies, reconfigures, provisions, those go to the witness. So you do not need to have multicast on the witness as well. It can be L3 and a routed network. To get to the witness, doesn't have to be multicast. The latency requirements between the data and the witness site is 200 milliseconds. Again, that's because there's no I/O going there. So 200 milliseconds is okay. That number is more flexible, up to 500 milliseconds for robo, but for stretch it's 200. The bandwidth between the data and witness site is recommended to be 100 Mbps. Now, this calculation depends on the number of witness components that you have, and not the writes, because again, there's no I/O there, so it's on the number of components. And roughly, it translates to 2 Mbps every additional 1,000 witness components. And for those of you who are not familiar with that, everything on vSAN is an object. So VMDK is an object, a swap is an object, a suspend file is an object, a snapshot is an object. Every object can have several components. In the most common case, with failures to tolerate one object corresponds to one witness. So usually one object means one component, in this case at least. So 1,000 components, 2 Mbps. All right, so again, this says that no I/O on the witness, mostly relevant during provisioning and things like that. The reads and writes do not go to the witness, so you don't have to worry about that. And the sizing for this doesn't depend on that. The only other thing here is that we do heartbeating to the witness as well. Along with the host between the sites, we also heartbeat the witness. And if I believe it's it's in there, 5 seconds.
Yeah, 5 seconds.
If you don't hear from the witness for 5 seconds, there'll be a network partition. All right. Let's see here. So, I'm sorry, was there a question? Oh, go ahead.
Is there a way within the product to actually regulate how much bandwidth you're using between your two primary sites, or do you regulate that with QoS?
So you could always do it either layer 3 DSCP tag or COS. Network I/O control will regulate at an individual host, but obviously if you have multiple hosts fanning up to a single instance in that case.
Or just think about it from the perspective, if you have a lease line between the two sites, you have X amount of bandwidth, and you have multiple uses for that line.
Typically with that, if it's a layer 2, you apply COS tags. So if it's a leased line, they should honor those. And you may have to call them and make sure they apply a class map.
So there's nothing in the product that would sit there and go like, we'll use 200 megs for...
So if one host is causing contention, network I/O control would detect that. But if you have multiple hosts causing contention, network I/O control doesn't operate in a global, and particularly a multi-cluster way. What if you have multiple vSAN clusters feeding up? They're not going to be aware of each other. So from that type of contention, I mean, there is contention in terms of if something else was being impacted at an individual host, it'll throttle. But when you've got potentially multiple clusters, things feeding up, for that, you're going to just use your standard. Generally, people apply a COS value of 4, I think, for storage seems to be a common one. So
there are some other ways in which you can kind of throttle that. Natively within vSAN, that's something we could consider in the future. It won't be at a network level, but we know what goes across, and there might be ways we can do something to throttle those. So natively in vSAN, that's something we can do in the future. All right.
appliance sizing.
Okay, yes, appliance sizing. So this is not related to networking per se, but let's just go over this real quick. So the Witness VM comes as a prepackaged OVA. It comes in 3 flavors, large, medium, tiny. This depends on the number of witness components, and there's a guideline over there. 45,000 witness components is a large, and so on and so forth. Let's go here. Okay. Okay, so this talks about something interesting. I must apologize. I noticed while John was presenting that we have a typo up here. So these networks are actually the same. They're not 192 and then 10. They should be on the same network. But the witness, so between the two hosts is where the I/O actually flows. So that's where we want a private network, something that's not routable. But the witness, on the other hand, could be co-located with your vCenter or something, and could be on a routable L3 network. So in order for the data sites to be able to talk to the witness, you would have to configure static routes or some other solution like this. Now, at this point, I would like to mention that for our robo, There's a solution we are considering where you could technically separate out the two traffics, the witness traffic from the data traffic, have multiple VMK NICs, one for data traffic, one for witness traffic. And that's something that we are working on for Robo. So if that's something you'd be interested in, definitely do talk to us after this, and we can probably get you on an RPQ program. And because the technologies behind Robo and Stretch are exactly the same, if this is something that you would like to see in Stretch as well, do talk to us after the session.
And the key benefit there on that two-node Robo is by separating out the heartbeat traffic, and you have a data-only path. At that point, you can now run crossover cables on that two-node. So if you're remote branch sites, you can be running full 10 gig for vMotion and vSAN at that point without having to have dedicated switching for that purpose.
But that's only for Robo.
Yep.
All right. Now this goes into a little bit more details about how we calculate those bandwidth requirements. So this one is the bandwidth requirement between the data sites, and this is based on the number of writes. Like John was saying, reads, we do prefer local reads because we don't want to do a read over 5 milliseconds, but for writes, we do have to go across. So the typical calculation is the number of writes times 1.4, and the 1.4 comes from some extra headers that we slap on top. It's not just plain IO packet. There's some headers in there, so you just add 1.4. We also account for 25% more headroom in there for rebuilds or resyncs, because if a disk or a host fails, we have to go across that link. So the write times 1.4 times 25% is what gives you how much bandwidth you really need across the site. So there's an example there with 10,000 writes. You can assume 4 KB block size. If you have 4 KB block size, that translates to 40 Mbps or 320 M lowercase bps, megabits per second. And that's how you land up with 560 Mbps bandwidth requirement between the two sites.
And there is a bandwidth guide that it will explicitly outline this for those of you frantically trying to take pictures of this.
Right. The Stretch Cluster Design Guide has all of these numbers and all of this in much more detail. The next slide talks about the bandwidth requirement between a data site and a witness. And again, this is based on the number of components. I don't want to go in all the details of where the 1138 comes from and all of that. Again, the Stretch Cluster Guide explains this. So in a nutshell, it's 1138 bytes times the number of objects you have divided by 5 seconds. And this is all based on implementation details. But this number is more or less accurate. But a good rule of thumb, again, is 2 Mbps per 1,000 components.
And so for small sites, we got a couple of VMs. I mean, you can operate this on a DSL line or a T1 or DS1 or whatever. I mean, it's pretty light.
Yep. And again, the traffic separation thing, talk to us later, and we can give you some more details on that. All right, security. So again, even though this is across two sites, there's I/O going there. So we don't want this to be like a routed network or a public network or something like that. The link between the two sites should be private, should be just like any other links on a regular vSAN cluster.
Or a storage network in general. I mean,
exactly.
You don't want to expose your NFS or your ISCs to the world. So the same best practices follow.
Yep. So that network must be private. The witness, on the other hand, you can use VPN or some solution like that. That usually works pretty well. I think most people do use VPN for that. Right?
Yep.
So yeah, I think that's about all I had. That's pretty much all we had. John here has several Twitter followers, so he's good. Me, on the other hand, not so much. So
I heard Anchor bet he could get more followers than Duncan. So do we have any questions? We've got a microphone here. We got some time here, guys. Come on, somebody's got to have a question. Go for it. So you will get a notice that says that you're in a degraded state because you don't have full quorum, but everything keeps operating. So if your witness fails, the primary site keeps running. What will happen is unless you're using forced provisioning in your policy, you will not be able to create a new VMDK. Now, if you want to be able to override that and be able to create something without it having full redundancy, you would set on your SPBM policy forced provisioning, and that would allow you still to create in that situation.
Yeah. So this acts like regular fault domains where each of them is a fault domain. Witness going away is like one fault domain going away. You still have both copies are there. You can continue I/O. And like you said, you can even provision with forced provisioning. We just resync and make sure everything is up to date, and we'll be good to go. The only interesting case in Stretch or Robo is if the link between the data sites fails, just the link. Now you have a witness that can see both sides, but you have two sides that cannot see each other. In that case, one of the sites is configured as a preferred site. The witness forms a cluster with the preferred site, and the preferred site can make progress, whereas the other side is network partitioned out. You restore the link again, we resync, everything comes back up, and you can keep going. But I/O always goes on in one failure.
There is no way, trust me, I tried a lot in the lab to create a split brain. We're fairly adamant about that from a design perspective.
Except if we do enable the split network.
Oh, yeah, I have to do that. But so the number of objects, there's a fixed amount of metadata for each object that has to be synced. And so the more objects, it's got to check on the state of those back to the witness.
So the number of objects is for the entire cluster. So it doesn't matter how many hosts those objects are spread across. It's how many objects you have in the cluster. Based on that, we calculate the...
And that question was, why is the bandwidth per component, not per host for the recording? So any other questions? So the question was, how many people actually in production are doing layer 3 multicast versus layer 2? I will say the overwhelming majority are doing layer 2. That said, we have layer 3 in plenty of cases, and that's often a lot of very large shops who they're using fault domains or things like that. I just had a discussion with a Fortune 500 who's doing a layer 3 topology deployment for their business critical application. It's going to be their primary mainline e-commerce platform, of which they account for 90% of their business. So people do it for mission critical environments where they consider a broadcast domain a hard fault domain, and they're just not willing to accept that. But for most people, they stick with layer 2 just for ease of management and deployment.
What do you guys use? Just curious. Oh, okay. Yeah.
On the left here. Why I don't recommend the FEX. The question was, why do I not recommend a FEX or a Nexus 2K? So a normal switch, or even a hub, if I send traffic to one port, it can go straight to another port. A FEX is a very special device, to where it's basically like a fake line card that's been an extension of a 5K or a 7K, for those of you who don't live in Cisco land. And any type of traffic that goes from one port to another, what's known as east-west traffic, has to go route all the way back and all the way there. And that creates a throughput bottleneck. Now, if you deployed 240 gig uplinks back to your 5K or 7K, 80 gigs of traffic, you're probably not going to have too many problems. But the other issue also is FEXs, because they're a bit older than the tooth at this point, they have lower PPS, they have lower buffers. They're just not as fast as a modern Trident 2 based platform like in Cisco, like a 9K or something. The question was, have we done any testing on the new 2300s, which actually have an east-west capability? No, I would say I personally have not. I'd have to check with R&D and customers. So, but if the key thing we're looking for there is nothing. I don't have any hatred specifically of Cisco FEX. It's just anything that lacks an east-west. As you scale, you're going to potentially run into problems, and particularly it's going to be a problem when you have a host failure and you're doing a full rebuild, and that's where you're potentially slamming those links. Would be my concern. So, next question.
If a customer already has a decent cluster deployed using standard switches and migrate to a VDS, because currently you can only do that by dropping down to RVC to reapply the network configuration. Is that something that's acknowledged now?
There's a guide from GSS. So the question was, is if you want to migrate from a standard switch to a VDS, maybe you started with standard and you realize the VDS is awesome, you want to migrate, because the VDS is awesome. There's a guide. I saw GSS was putting up the finishing touches. They're going to wrap into a KB bow that actually outlines the migration process. You create a second VM kernel on all the hosts that's on the other port, and then you basically go back and remove the other. It's a little more complicated than that, but look for a KB guide or just open a ticket with GSS. I was talking to the escalation team, and I've already seen that guide. It looks rather nice.
And there'll be no downtime or none of that.
If you don't see it in a couple weeks, when I have some sanity, hit me on Twitter, and I can find it for you.
Mm-hmm.
Yeah.
Stretch up cluster. Is there any performance hit if you're going from like 1 millisecond to 4 milliseconds?
So the question is, what is the performance hit on stretched clusters if you go from 1 millisecond to 4 milliseconds, for instance? So yes, there is. In fact, there's an excellent white paper our PE group has put out that discusses the performance implications. So reads, because they're always from local, there's pretty much no real hit. It's writes where the hit comes because we have to write both copies of the data and acknowledge it across that path. So you're basically adding 4 milliseconds of write latency.
So the other case of performance implications is resyncs. They become even more expensive now, especially, and even failure cases. So if your local copy has failed, then even reads will have to go across the wire. Resyncs have to go across the wire. So those are some cases, failure cases.
If you undersize that link, yeah, a rebuild could impact performance.
Even when a site goes down and comes back up, it can be expensive to resync across.
But there is a paper out there that actually outlines this. The PE group put out where they even show benchmarks during a failure of a site and during the recovery and resync of a site. So I would go check that out. Does that make sense?
Yeah, I'm just trying to think. I'm looking at a stretch cluster, it's 3 to 4 milliseconds.
Yeah.
I
And
was wondering if I should be thinking of something.
so the other option is if that write latency is too much on a stretched cluster for what you're willing to accept for write latency, is you run 2 separate vSAN clusters and then you run vSphere replication. We can have a 5-minute RPO target between those sites. And so that way you have a full copy. Now that's going to be active passive and you're going to use something like SRM potentially to orchestrate failover at that point. But if you want to get that sub-millisecond latency and your second data center is too far away to be able to deliver that, this is how you switch to asynchronous replication. Or if you need a 0 RPO at that point, you're going to need to look at application-based replication.
Yeah. Although if you're looking at a 10 Gbps link between the sites and 3 to 4 millisecond latencies, that's an excellent candidate for stretch cluster, but with the caveats that you just said.
Yeah. Got a question here? And a grin, an evil grin.
No, it's not an evil grin. It's just, I just poke holes on things. There's no holes here. It's just kind of like saying that I was really super excited about the vSAN and I implemented a cluster really same time that I already invested in some arrays.
Yes.
Where do you see, in those kind of situations, where do you see customers kind of
Okay, so the question is, I actually used to be one of these. So the question is, if you've already invested in existing arrays and you're looking at vSAN, like how do you make that work? So unlike some other HCI vendors out there, I lack the hubris to stand on the stage and tell you that 100% of your storage will always be vSAN. Like that's crazy talk. That said, I think there's a sliding scale of use cases. Sometimes we take from the bottom up in terms of starting with robo and small cases and work to a certain point. Then people do something crazy for tier 0, some exotic NVMe monstrosity. The other time, sometimes we're the tier 0 and we work our way down and then someone gets a bulk cheap modular storage because they've got 2 petabytes of cold data they never look at. Go buy an iSeries, whatever. How we work together, and this is the beautiful thing that I'm really excited about, and I encourage you to go to Pete Fletcher's vVol presentations, they're all over the place, is we both use SPBM. We both use storage space policy management. So the exact same way that you set your vSAN policies, if you're using vVols with your traditional array, is exactly how you're managing that array. In fact, within the HCI space, I think we're the only ones that I'm aware of using SPBM. Mm-hmm. And because we lack that hubris to say we'll be the only storage ever in your data center, we want to make sure we play nice with everyone else.
And another thing that works really well is you can put your arrays on eBay. And
but it's one of those deals to where, your old array, after you bring in an awesome all-flash vSAN with NVMe, you need a backup target. It's in a different fault domain. You need it, or a DR, things like that. But no, I mean, really the secret there of how you're going to get your storage team, and you can use VROPs and have full deep visibility into both. Our tool sets are built to work across both.
You can also use it whenever you need file services or file systems and stuff like that, in View and other cases.
Is there plans to add multiple tiers in a single cluster so that you can distribute over, if you've got some hosts that are purely all-flash currently, but you still want to add a tier 1, tier 2 for your large petabytes of data that you're running?
So the question is, can you do multiple, like right now, it's a 2-tier architecture already, but the idea is could you do further tiers so you could have an all-flash, and then you go to a super cold using nearline SAS. We're not doing that today. That said, this is a very frequent question that comes up, and I encourage you to find our product managers who are roaming about and talk with them about that idea and discuss the business use case.
Usually, people end up breaking clusters up, but that does come up a lot. For
now, what I have seen some customers do is they'll do a hybrid that's got all the ice cold data with the giant spinners, and then they'll do all flash for everything else. Although what I will point out is all flash, I can go to Dell.com and go, grab a random R630 PM863 base drive that's on the HCL certified today, without any discounts, not me, they knowing I work for VMware, 54 cents a gigabyte. Then you do distributed RAID 5 and RAID 6 on top of that. Then you run dedupe and compression with a 4K fixed block. All flash is pretty darn cheap. And it's denser because you can get the 3.84 terabyte drive and a 2.5-inch form factor. So, I've seen people put a petabyte and a half in a cluster. It was only 24 hosts. So we can do a lot with all flash. Don't assume you have to go to those slow drives yet. Yeah. Oh, so for gotcha. So the idea is you want like a backup or a cold tier in addition to like a small flash turbo. So an interesting suggestion I saw recently is, have you seen the Dell Vertex platform? So we don't support the PERT controller, which is basically a fake, Avago storage array is what it is. But what you could do is there's local drive bays, and you can get those configured with all NVMe. And Intel's just releasing very reasonably priced all NVMe. So you could do a 2-drive NVMe, do an all-flash cluster there, fully supported, and then use the PERC 800 series, that shared JBOD with the large form factor, to act as your bulk target. Maybe run your VDP backups or your Commvault or your Veeam or whoever you're using for backup there, and have that be your backup target. That way you have a landing zone and then you replicate out. So that was, and you can do similar things also. But that's something I have seen. Sometimes people will do something else, or they'll just have a local RAID set of large form factor drives in addition to the all flash vSAN for that purpose.
So, question over here.
In your experience with dealing with your customers, what kind of data center interconnect technologies are you seeing most of your customers use?
I was going to say, so one thing the question is, what are we seeing for data center interconnects? And you're just talking specifically for layer 2 overlays, VXLAN, OTV. So obviously we see people use OTV. We've seen customers with ACI, believe it or not. We've seen customers with VXLAN and so forth. One thing to note is between the two primary sites with the data, abstracting those, they work. It's just a matter of can it perform and does it have problems, or you have issues. So be aware of that. One case to watch out for with OTV and some of these systems is don't stretch them to your witness site, because now you've created a weird spanning tree. You can actually end up with an L-shaped traffic flow to where one data site talks to the other site through the witness. I saw someone actually want to do OTV all the way in a big triangle. That's bad. Please avoid that. You can end up actually with L-shaped routing with layer 2s.
That causes all sorts of problems with HA as well. So.
Yeah, among other things. 400 milliseconds latency. And there's ways to weight that and stuff, but then I'm like, okay, but if you have a network partition, you're going to have to go physically yank this link.
So I think we're getting kicked out.
I think we're getting kicked out. Wrap it up. All right, guys. Appreciate it. We'll be standing outside for questions.
Thank you, guys.